Hi everyone, in this video we are going to go over classification of matter, properties, and changes. Okay, so please read OER textbook chapter section 1.1 to 1.3 together with this lecture lesson. Okay, so after you finish watching this video, you should be able to start doing homework. Okay, so the homework that you are going to be able to do would be homework chapter 1.2 and 1.3. Okay, so that would be the homework. So start working on that so that way you can get it out of your way. Okay, so for chapter 1.1, chemistry in context. So this one would give you an overview of what are we going to learn exactly, or what chemistry exactly, and things like that. So this would be the self-study. It would be reading assignment. It's not long. Okay, so read through it. And after you finish, then you can start working on the exercise that listed in the lecture manual, and the answer key for that would be posted on Moodle. Okay, so under the DIY solution, okay, so you'll be able to see the solution for that. So I would like you to actually read it first and then answer the question and then check your answer to check your understanding whether you actually answered those correctly or not. Okay. So let's start with, before we actually get into the detail of everything that we're gonna learn for the rest of the rest of the term, I would like to establish of like what is chemistry exactly, right? So that way we know the scope of what we are going to look at. So pretty much chemistry is the study of properties of matter and also the behavior of matter as well. So what is the matter? Then we have to define that further. Okay, so pretty much matter is anything that occupies space and has mass. So what we are going to look at is we are going to look at how this matter exists, right? And what are the composition of matter and how do they change the behavior when you like alter some of the property and things like that. Okay, so pretty much what you are going to look at in this lecture video would be how to, because we're going to study the behavior of matter, so we're going to looking at the changes, right? So the changes, and also how to classify them to learn about their properties too. So lecture 1.2 will talk about that. Okay, so what I would like you to do before you actually continue watching this video, I would like you to read textbook chapter 1.2 first. Okay, so I would like you to pause this video, read chapter section 1.2, and also complete exercise 1.4. Okay, so let's pause the video now, read chapter 1.2 and complete exercise 1 to 4 for this before class activity. Okay, and after you're done, resume the video again. Okay, so pause it now and then resume when you're done. All right, I hope that you already finished reading the assignment and complete the exercise already. So let's check your understanding. Okay, so why are astronauts in space said to be weightless but not massless? Okay, so according to the reading assignment, you will see that the weight depends on gravity, right? So in space, the force of gravity is extremely small. So that's why the weight is essentially absent, right, in space. However, mass is the measure of the amount of matter in it. So it's never gone, right? So that means you are going to see to hear a lot when whenever that we talk about mass. When we talk about matter, I would use the word mass more often than weight, right? Because mass is the actual measure of the amount of matter in it. Okay, so let's take a look at exercise 2, right? So according to the reading assignment, right? So you should be able to answer this problem. So let's check your answer. Yeast converts glucose to ethanol and carbon dioxide during anaerobic fermentation, as depicted in the simple chemical equation here. So pretty much what you have is you have glucose, right, that convert to ethanol and carbon dioxide. Okay, so note that carbon dioxide is a gas, right? So I'm just gonna use these parentheses and G. Okay, so parentheses G refer as gas. Okay, so if you have 200 grams of glucose, so if you have 200 grams of this, okay, these 200 grams of glucose fully converted, okay, what should be the total mass of ethanol and carbon dioxide? So it's asking you what should be the mass of this, right? So that's what it asks you here. The answer would be what? 200 grams. Why? Well, because according to the law of conservation of matter, right, whatever you start with, you have to end up to having the same mass, because matter is conserved, right? It's just changed from one form to another form, but the mass of it will have to stay constant, right? So which is 200 grams. So now think about this. What if the fermentation that carry out is in an open container, right? So if you do this fermentation and it's in like open container, right? So this is like a brewing process right here. Right? You make ethanol, right? Which is drinking alcohol. Let's say you like brewing that in like, I don't know, just, like some open container. Would you expect the mass of the container to and content after fermentation to be less, greater than, or the same of the container of the content before fermentation? Okay, so let's say like if you have 200 grams of this glucose and you have it in the container, right? So actually you have container right here. You start with 200 grams in open container. At the end, would you think the mass of this would still be 200 grams, greater than 200 grams, or it would be less than 200 grams? And why, right? So the answer is it would be less than less than what we originally start, right? Because what? Because as I mentioned before, we are creating carbon dioxide, which is the gas, right? So the gas will escapes, right? So it's making the mass of the whole container to become less. Okay, so that's why pretty much when you are doing something, you're not going to get exactly the same mass as you start, because some of the product might escape already. So you have to account for those as well. Okay, so the last one is, if you have 97 grams of carbon dioxide that is produced, what mass of ethanol is produced then? Let's say you start with this 200 grams of glucose, right? So you have 200 grams of glucose. You know that the gas that escaped would be carbon dioxide is escaped 97.7 grams. So how much ethanol did we produce then, right? So how much is that? The answer would be what? 102.3 grams, right? Because it's going to be the difference between mass of glucose minus mass of carbon dioxide to get the mass of ethanol, right? Because according to the law of conservation of matter. Okay, so next, exercise 3. Okay, so the state of matter that is rigid has a definite shape and also has a fairly constant volume, that is solid. Yep. State in which matter has neither definite volume nor shape, that would be gas. Yep. State of matter that has a definite volume but indefinite shape would be liquid, right? So liquid would be like between solid and gas. Okay, so exercise 4. Okay, so according to your reading assignment here, let's take a look at the first one. Okay, so the answer for the first one is molecule. Okay, so molecule are bonded, is the bonded collection of 2 or more atoms of the same or different element. Okay, so we're going to take a look at what is element next. Okay, so the next thing is, what is it for the pure substance, right? What is the answer for second one? The answer is compound. Okay, so compound is a pure substance that can be decomposed into 2 or more elements. Okay, so I'm going to elaborate this further in just a few minutes. Okay, so let's check your answer first. Okay, so the next one would be homogeneous mixture, which is the combination of the substances with a composition that is uniform throughout. Okay, and the element would be the substance that is composed of a single type of atom, a substance that cannot be decomposed by any chemical change. Okay, and then atom would be the smallest particle of an element that can enter into a chemical combination. Okay, and then the last one is heterogeneous mixture, would be a combination of substances with the composition that varies from point to point, doesn't mix uniformly. Okay, so let's take a look at those and check your answer. If you answer all of this correctly, that means you already know the terminology for all of these that we are going to use. Okay, so Matters that we are going to take a look at would come from these elements, would come from this combination of all of these elements. And note the new element here. We have like 4 new elements that has the name given by IUPAC in 2016. Okay, so pretty much if you combine all of these elements together, that's what you are going to make compound in a fixed ratio. Okay, so for example, if you have 1-to-1 ratio between sodium and chlorine, you are going to make table salt, which is sodium chloride. If you have 1-to-1-to-3 between calcium, carbon, and oxygen, that's what you're gonna make calcium carbonate, which is chalk. Okay. If you have the ratio of 2-to-1 for hydrogen and oxygen, you are making water. But if you have the ratio of 2-to-2 or 1-to-1, actually 2-to-2 in this case, we are making hydrogen peroxide. Okay, so note that the subscript matter. The subscript tell you the ratio. Okay, so the subscript written here tell you the ratio. If the ratio change, you are changing the identity of the compound. Okay, so changing subscript. Okay, you change identity of compound. If I don't have space here, you change identity. Okay, so never ever change the subscript, because if you change subscript, it becomes something else. Okay, so I have a joke for you that will actually help you to remember this. Okay, so the joke is that there are 2 guys go to the bar, and the first guy asked the bartender for water. So he said, I would like H2O, please. And then the bartender asked his friend, what would you like, sir? And his friend responded, I would like H2O too. So the second guys who received H2O2 drink and die. So that's a joke. I hope you get that, right? So because his friend got water, but himself, when he ordered H2O2, he actually ordered hydrogen peroxide, right? So when he drink it, you know, it's just, yeah, it's not pure water. So it's just so that's just a joke that will help you to memorize here. So never ever change the subscript, because you are changing the identity of the compound. You are talking about different compound now. Okay, all right. So so what I would like you to do next is that I'm going to summarize what we just talked about. Okay, so this part is the review part. Is not in your lecture manual. If you want to actually like write this down, you are welcome to, because it's going to help you to understand a little bit better. Okay, so if you go back to here, this periodic table, you can find this on the back of the lecture manual. Okay, so if you want to know where you can access this, is actually in the back of the lecture manual. Okay, so actually go to here. So now I'm going to define this a little bit. So I'm going to compare between atoms and element. So pretty much element is what you already see, right? So we have like that amount of element that can mix together. So element would be the simplest. It would be like the substance that cannot be broken down. Is simpler substance, right? It's the simplest substance that cannot be broken down anymore. And atom would be the basic building block for that. So for example, if you have elements such as gold, Au, it can compose of several atoms, right? So that means atom would be like the basic unit of gold element. Okay, so I will give you a little bit more example in just a few minutes here. If we talk about copper, for example, you can talk about 1 atom of copper or 2 atoms of copper. Copper is an element, and you can have several atoms or just 1 single atom. So atom is just a basic unit of the element, right? Okay, so now let's take a look at molecule versus compound. Okay, so molecule would be when you have atoms bonded together via chemical bonds. Okay, it can be the same type of element, or it can be different type element. Okay, however, compound is when you have atoms of different type of element bond together in a fixed ratio that would form a compound. For example, H2O, this is considered to be compound because it's contain two different elements bond together via chemical bonds in a fixed ratio. How do you know it's a fixed ratio? Well, you can look at the subscript for that, right? However, molecule H2O considered to be a molecule too, and it's also considered to be a compound because it contains more than two atoms bond together in a chemical bond. And if you have just H2, this is also considered to be molecule because it's contain only two atoms of hydrogen bond together. So this is molecule of hydrogen, right? Gas, H2 is hydrogen gas. However, H2 is not, this H2 right here is not what do you call compound because it contains only one type of element. Okay, I hope you understand that. So again, so if I talk about this one right here, right? So, oh, sorry. So, oh, let me, I did that. So actually, let's do different color. Okay, so compound would be H2O, right? Molecule can be H2O2, H2O. However, H2, molecule of H2, oh, sorry. This is considered to be only molecule, but not compound, okay? Because compound need to have two or more type of element. Okay, so that's how you differentiate them, okay? So the next one is the difference between pure substance versus mixture, okay? Pure substance would be substance that composed of only one type, okay? Mixture would be composed of like two or more type of substances, right? We can break the mixture into two categories: homogeneous versus heterogeneous. Homogeneous would be the mixture that mix and is turned into a uniform mixture, right? The other one would be not uniform. An example of homogeneous mixture would be something like what is it? Like salt solution, right? Salt water. Okay, that would be homogeneous. Heterogeneous would be what, like a bowl of cereals, for example, or chicken noodle soup, right? Chicken noodle soup, because they mix together, but it's not uniform, right? They used to see chunk of celery or chunk of chicken or noodle and things like that. But this one, you are not able to separate salt and water, right? You just see them uniformly throughout that solution. Okay. All right, so with that being said, let's take a look at actually an example of it. Okay, so I'm going to let you pause the video for this so that way it's reinforce your understanding what we just talked about earlier. Do you actually understand it, right? So this is how you test it. Okay, so what I would like you to do is that I would like you to look at these. I would like you to look at these what do you call list of substances. And what you need to do next is, one is you need to classify them, right? How would you classify the following items, right? How you're going to group them? That's pretty much what it asks you. What characteristic did you look at in order to decide like in what group you need to place them in, right? And did an object fit into more than one group? Why or why not, right? And also the last question would be, why do you think chemists like to classify matter, right? So why do we learn about classification of matter anyways, right? So that's what we're going to take a look at. So I would like you to take a few minutes here and think about how can you group them, and can you make more than one group, right? So let's think about that. And I'm going to give you some hint, which is the chemical formula of this. Okay, so I'm going to give you some hint, which are the chemical formula. Acetic acid, the chemical formula would be H3CO2H. Okay. What else? Aluminum metal would be Al. Okay. Air would be N2O2 and CO2, and then others. Okay. Brass composed of copper, zinc. Okay, so Kool-Aid, you probably know that already, right? It's contain what, sugar, dye, and things like that. Okay, so so let's take a look at this real quick. So let's pause the video and group of these, and then resume the video again when you finish. All right, so I hope that you already finished at least group, make at least one group. Okay, so if you have more than one group, that's great. Okay, so let's take a look at this. So we're gonna classify all of this. Okay, so some of you might say like, oh, I see for sure. This is solid. This is solid. Can I just group them together using the state of matter that they are solid and these are liquid, right? You can group them together. Actually, let me use different colors so you can actually see it. Can I just use this as, you know, like since it's liquid, can I group this as liquid, right? And this is another solid right here, right? So can I group that as solid? The answer is yes, right? So this is another liquid too. Let me actually, that's liquid, that's liquid, that's liquid, right? And then we have one gas. The answer is, yeah, you can do that. There's nothing wrong with that, right? I see it too. That's how I would do it too. Some of you might be like, hey, I also noticed that some of them like pure, right? For example, you have just chlorine here, and these are the mixture, right? So maybe you can say like, you can group this as mixture, right? And then this would be like pure substance or something. The answer is yes, you can do that too. Okay, so there is no right or wrong for this. Okay, so let's take a look at what I have here. So if you want to classify them by the composition, you can do it too. So that's another classification of matter, right? So by composition. Okay, so how do you do it? Okay, so the way that you do is that you are going to look at matter, right? You're going to consider the variable of the composition. If they contain only one single type of substance, that would be pure substance. If they contain more than one type of substance, that would be mixture. Okay, and if it's pure substance, then you can break it down further into element or compound by looking at the different type of the composition, right? So if it's contain only one type of element, it would be element. Is contain more than two type of element, it would be compound, for example. And then when you're looking at mixture, you can looking at how they mix together, right? If they mix uniformly, that would be homogeneous. But if they don't mix uniformly, then that would be heterogeneous, right? So what are they that fall into this category, right? So for example, brass would be homogeneous. You might be like, wait a second, why is it homogeneous? Why is it not compounded? The reason for that is because brass composed of a mixture of zinc, actually mainly copper. Copper add together with zinc, they mix uniformly in a solid state. We call this an alloy. Okay, so an alloy is the mixture of copper of like any metal mixed together. In this case, this alloy we call brass because brass made of copper and zinc. They mix together. They do not form any chemical bonds. Okay, so they don't form chemical bonds in a fixed ratio. That's why they are not compound. Compound have to be fixed in a certain like ratio, right? For example, water would be H2O, right? So this one, we don't actually have the certain ratio for copper and zinc, right? So we don't have a fixed ratio for that. Okay, so that's why they consider it to be homogeneous. Kool-Aid, as I mentioned before, is a mixture of what, like sugar, dye, right, and water mixed together uniformly. So that's why we consider it to be homogeneous. So for air, it contains several gases. For example, nitrogen, oxygen, right? It contains argon too. It contains carbon dioxide and things like that, and other stuff. And as you see, again, air doesn't consider to be compound because all of these gas are together, not in a fixed ratio, right? They are just mixed together. So these are molecule. Sorry, this is not. So argon is atom, right? So atom is just one. So molecule would be more than one atom combined together. Okay. So all of these are just mixed together uniformly. Okay. Heterogeneous would be, for example, oil and water. They don't mix uniformly throughout, right? You see the separation of oil and water. Rice and salt, right? You see the separation of rice and salt. Chalk in water, right? So if you let this sit, you will see that chalk will deposit down in the bottom, and then you have like water solution like above of it, right? So that's why we consider it to be homogeneous. Okay. Oh, sorry, heterogeneous solution. And then element would be aluminum because contain only Al. Okay. Chlorine would be an element as well because it's Cl, but the chemical formula you will see is Cl subscript 2. We're going to talk about this later, why it's subscript 2. So pretty much the chlorine would be considered to be a molecular element, and aluminum considered to be atomic element because only one atom. Okay, so let me write this. This would be atomic element. Okay, this would be molecular. Molecular come from molecule. Is the element that present as a molecule. Molecular element. So in nature, chlorine would present as a molecule, which means it need to come together with another atom of chlorine. But aluminum would be just one single atom. So that's why we call atomic element. Okay. All right, so let's take a look at the next one. The next one compound would be vinegar or acetic acid, okay, because it contains several elements. It contains carbon, hydrogen, and also oxygen as well in a fixed ratio. Okay, if you change any of this ratio, you are changing to a different compound. Okay, so that's why we call compound here, because it's contain 2 or more elements that bond together in a fixed ratio. Okay, so I hope that you actually start to see to get some sense of the difference between all of these. Okay, so let's check your answer. Did you get it right? Most of them. Okay, so now let's take a look at state of matter. You can classify by state of matter too, as I mentioned before, right? So for example, solid, liquid, or gas, right? So there's nothing wrong with that, right? So you can do that as well. And the take-home message is that why do we care? Why do we need to classify them? You are going to see a lot of this classification throughout the whole term. The reason for that is because we have to classify them into a certain group because we want to study their properties and also behavior more easily. Okay, if you are talking about solid, liquid, or gas, if you group it that way, then we are going to study their property and behavior in a certain way. Okay, so that means most of the time you are going to see that chemists group them in order to make sure that we are able to predict the trend and also study their property and behavior more easily. So that's why there are so many type of classification, right? So there is no correct way, like there is no incorrect way to do it because it just depends on what criteria that you are using. Okay, so pretty much throughout this, you are going to see different category of different matters, right? So we can put them into a different category because we're gonna want to learn about their property and behavior easier once we group them. Okay, so let's take a look at exercise 2. So since already you know about a little bit about solid, liquid, and gas, I would love you to sketch a picture of solid, liquid, and gas on a molecular level here. When we talk about solid, it's being rigid, right? And excuse me, and have a definite like volume and things like that. What would that look like to you? I would like you to actually pause the video and do that. Okay, so kind of like draw a picture of the solid, like molecular level of solid. What would you think is would look like? Would it spread throughout, or will they like group together, fix together, right? Excuse me, and how is that different between liquid and gas? Okay, so I would like you to do that. Okay, so let's pause the video and then do that. Okay, then resume it again when you finish. All right, let's check your answer. Solid would be because they are in a rigid, right? So that means the molecular level would be packed closely in a fixed location. So it would look like that. It's fixed together. Okay, so the motion that associated with this, it would be only vibration. So that means each of these atom of solid, right? They are going to only vibrate. They're gonna only like shake a little bit. They cannot move because they are fixed together in a fixed location. Okay. Whereas if you talk about liquid is going to pack a little bit loosely, therefore they are going to be able to move a little bit. That means they are going to be able to vibrate a little bit, and they are going to rotate too. So they're gonna rotate around, right? So they're gonna rotate around like that, right? So they're gonna be able to like rotate a little bit too. Gas would be freely to move because gas dispersed throughout the container, right? So that means in this case, the gas molecule would just be able to vibrate, rotate, and also translate. As well, translate mean moving freely, right, from one location to another. So that means these are the picture that represent different state of matter, right? So because they in the molecular level they are different, therefore you are going to see different behavior for all of these state of matter as well. Okay, so that's why we group them, right? And we learn about their behavior. All right, so the last part of this lecture video that we are going to talk about is the properties and changes. Since you already learned about matters, you know how to classify them. The next thing is we're going to take a look at their property and also their behavior as well. So the reading, so the before class activity that associated with this would be first, I would like you to read chapter section 1.3 of the textbook and then complete exercise 1 and 2. Okay, so I'm not going to go over this exercise. Okay, so I would like you to read it and then fill out into these two exercise answer. The answer key will be posted on Moodle. Okay, so after you finish, you can check your answer against the key on Moodle. It will be posted under the DIY solution. Okay, so you will see this is page 5, so it would be like DIY solution page 5, right? So click on it, you will see the answer for that. Okay, so let's actually take a look at so this one is in the additional handout. Okay, so it's not in the lecture manual, so you can find these. So your lecture manual, if you like look into like the printed copy, after page 136 you will see that there is the list of additional handout. So go down to that. So after page 136 of lecture manual, you're gonna find this additional handout, and let's take a look at that so that way you can follow with me here. Okay, property of matter. Okay, so property of matter, we can classify into two types. Again, we get into classification again, right? Because we are looking at different things. Okay, so if you are looking at physical property, it's going to be something that you see, it doesn't change the composition of it. But when we talk about chemical properties, that's when the composition of in the molecular level would change, right? So that's why we have to separate them. Physical properties would be something that we observe without substance changing its composition, as I mentioned before. But chemical properties would be something that we observe, but only when the substance change its composition via chemical changes. How do you know when things undergo chemical changes? You're probably gonna see some, like, for example, gas formation, or like light is being produced, right? Or heat is being emitted, or like color change, smell change, and things like that, right? So it's changing from one to another. For example, food spoil, that's definitely going to be chemical property, because you are not able to eat the spoiled food anymore because different composition than the good food before it spoil, right? For example, okay. Physical property would be, for example, if you have like sodium metal, things that you observe here, that would be physical property. For example, is color, right? It's shiny, silvery, right? The density of these would consider to be physical property, or the melting point when it's melt or when it's boil, or if you test it, how it tastes or how it smells, those are considered to be physical property. But when you put this sodium metal into water, it's explode, right? You observe light is producing. These would consider to be chemical properties, right? So the reactivity of the substance will consider to be chemical property. The flammability, right? How much, like how fast is become like what do you call, like react with the air and things like that, right? Toxicity, acidity, corrosiveness, those are part of the chemical properties. Okay, and once we already see the properties, then we need to look at the behavior or the changes of matter as well. Okay, so how they change differently. When we talk about property, we classify as physical and chemical. Same thing for behavior as well. We need to be able to classify them by physical or chemical. Okay, so physical, similar to what we mentioned earlier, it will not change the composition, but chemical, it would definitely change the composition. For example, when dry ice, right? Dry ice composed of solid carbon dioxide. When dry ice sublime, okay, so this is dry ice. When dry ice sublime, it's become carbon dioxide gas. So it's only changing from solid to gas. So this is an example of physical change because as you see, right, the carbon dioxide still is carbon dioxide. It's just changed the physical state. It doesn't change the composition. However, if you like burn something or react something, that would consider to be chemical change because you are changed the identity of the substances, right? Before you have propane and oxygen, but when react together, it becomes something else, right? It produces carbon dioxide and water and also energy as well. So these would consider to be chemical change because you change composition completely. They are become a new substances. Okay. All right. So to summarize that, the difference between physical changes and chemical changes would be one involve like physical doesn't involve with composition changing, it's only involved with the appearance, right, changing. But chemical change would it would what do you call like associate with the composition change, and it's going to transform into a different substance. Okay, so let's take a look at exercise 1. Okay, so according to what we just talked about, I would like you to classify the things that I underlined here, okay, and tell me those are considered to be chemical properties or physical properties, right? For example, pale yellow gas, is that physical or chemical? So this is going to evaluate your understanding. So I would like you to actually pause the video and complete this and resume the video again when you finish. Okay, let's do it now. All right, let's take a look at the answer. Okay, so I hope that you already finished this. Okay, so let's take a look at fluorine is a pale yellow gas. Pale yellow gas would consider to be physical property. Yep. React with most substances. Oh, the word react is the key word here, right? So it would be chemical property. Yep. The free element melt at. Okay, so when it's melt, it's changing physical state, right? Melt means going from solid to liquid. For example, like buttermelt, right? It's going from solid butter to liquid butter. So in this case, it's changing only physical. So it would be for melting and boiling would be like physical behavior or properties in this case. And it said that finely divided metals burn in fluorine. Okay, so when it's burned, I mean they react with a bright flame, right? So that would be chemical. 19 grams of fluorine will react with 1 grams of hydrogen. So react, right? That's the keyword. It would be chemical. Yep. So let's check your answer. Did you get it all correct? If you have any question for this, just make sure that you actually talk to me during the live session. Okay. Let's take a look at exercise 2 now. Let's do the same thing. I would like you to pause the video and resume again when you finish. Okay, let's pause the video now. All right, let's check your answer against my key here. So classify the following changes as physical or chemical. The first one would be physical. How do I know it's physical? Well, condensation is going from gas to liquid, right? That's the condensation. Burning of gasoline. Ooh, the keyword is burning, right? So it's become something else. Now it's produced energy and it's produced carbon dioxide and water, right? So that would be chemical. Souring of milk, of course, it's definitely changed composition of it. That's why it's become something else now, right? So that would be chemical. Dissolving of sugar in water, that would be physical. Okay, so things that you have not learned yet is the aqueous solution, is the AQ. Okay, so pretty much sugar is in solid state. Once it's dissolved in water, it's become aqueous state, which means that it just mixed together with water uniformly. So in this case, we consider it to be physical change because sugar before you dissolve in water is sweet, and after you dissolve in water, it's still sweet, right? It still have any chemical property the same. So this is only physical change. Okay, melting of gold. Okay, so this would be solid to liquid. That would be physical change. Yep. So let's check your answer. All right, so let's take a look at number 3. I'm going to let you do the same. Okay, so let's pause the video and resume it again after you finish. Okay, let's do it now. Let's pause the video now. All right, let's check your answer. So coal burning, that would be chemical changes, right? Ice melting, so solid to liquid, that would be physical changing. Mixing chocolate syrup with milk, you just mix them. Okay, so in this case, chocolate syrup with milk would be only physical changes. Okay, explosion, right? A fire cracker, that would be chemical changes. Magnetizing of a screwdriver, that would be only physical changing. Okay. All right, so let's take a look at exercise 4 and 5. I would like you to do the same thing. Okay, so pause the video and resume it after you finish them. Okay, so let's do it now. Now let's take a look at exercise 4. Okay, the volume of a sample of oxygen gas changed from 10 milliliter to 11 milliliter as temperature changed. Is this chemical or physical change? The answer is physical. Yep, because oxygen still is oxygen, right? The volume just expand. Exercise 5, a 2-liter volume of hydrogen gas combined with 1 liter of oxygen gas to produce 2 liter of water vapor. Does oxygen undergo chemical or physical change? The answer is chemical change. Yep, because oxygen now combined with hydrogen and is produce something else, which is water in this case. Okay. All right, so pretty much this is it for this video, right? So this is the review or the overview of what we just talked about, right? We're looking at classification of matter. We learned about their composition, the state of matter, and also the property, and also changes as well, right? So we look at all of those. My hope for you is that after this lecture video, you should start working on homework 1.2 and 1.3 right away. Okay, so let's do that. Okay, so thank you for watching.